Okay, we're going to talk about skewed data. Skewed data is when your data is lopsided. So here are three examples. We have a negative skew, all the way to the right we have a positive skew, and then in the middle we have no skew at all. So if you take a look at those, you can kind of get an idea as to which one is a negative skew, which one's a positive skew, and then what a data set that has no skew looks like. Well, when it has a negative skew, it's got what we see as this long tail. So it's got this long tail, and it's lopsided to the right, but that long tail is on the left. So this long tail is on the left. We call that a negative skew. Another important piece is that the mean is to the left of the peak. So the mean of the data is to the left of the peak. So that's why some people are going to call it skewed to the left. I'm going to use green here, and that's why some people would call it skewed to the left. So a negative skew is when the data is skewed to the left. That means the long tail is on the left-hand side. The mean is to the left of the peak. Then we have what's no skew. This is completely a normal distribution. It's perfectly symmetrical, so you have just as much data on the left-hand side of the peak as you do on the right. And this peak is where the mean occurs, the median occurs, and the mode. So the mean is equal to the median, which is equal to the mode. When all three of those are equal, you end up with this normal distribution. For data to just fall like this naturally is highly unlikely. However, we try and get it, sometimes when it's as close as possible, we will still call it a normal distribution. So it may not be exactly perfect, but when it is perfectly symmetrical, it's called a normal distribution. There's no skew to it at all. Then we have skewed to the right, and skewed to the right is what is called a positive skew. Just checking my colored highlighter there. So I'm going to use orange here. Skewed to the right is a positive skew. It's when this long tail is to the right hand side of the data. Your mean is to the right of the peak. So the mean is to the right of the peak. And here's a real world example. And this is what I'm talking about, where it's kind of jagged here, but it's still going to appear to be skewed to the right. The mean is to the right of the peak. So this is skewed right. When it's skewed left or right, that means the mean is not equal to the median. So many times when I grade a test, for instance, and I'm looking at what the average score is for students, many times students are going to ask, what was the average? What was the class average? It's not about the class average as much as it is about the median, because when you take a test, you usually have data that was either skewed to the left or skewed to the right. So is it better for the data to be skewed left or be skewed right when taking a test? If we're looking at test averages, if we have 100% over here on the right, we definitely want this to be skewed to the left. So we want we want the mean to be to the left of the peak. Now, what that means is, here's our peak. What that means is that our median is to the right of the mean. So half our data is above the median, half the data is below the median. And the mean is going to fall in the lower half when we're skewed to the left. So when we have this data that's skewed to the left, we want the median score. The median is more helpful. So the median is a more reliable calculation than the mean is whenever we have skewed data.